Hello and welcome to Pytechie. Today's topic is data distribution. So, when we look at the data sets, we are not just seeing numbers, we are uncovering a story. Data distribution is a map that shows us how values are spread, clusters, or skewed. From bell curve to outlier, it reveals the hidden pattern that shapes our understanding. In this segment, we will explore the types of distributions, how to visualize them, and why they matter in everything from business decision to scientific research. Let's dive into the blueprint behind the number. Now, let's see what is a normal distribution. A normal distribution, also known as a Gaussian distribution, is a bell-shaped curve that shows how data is distributed around the mean. These are the few feature or characteristics of normal distribution. So first one is a normal distribution from a perfect bell curve. Second one is a symmetry. The left and right side of the curve are mirror image of each other. So most of the data are fall around the average. In a normal distribution, the mean, median, and mode are equally and located at the center of the curve. Total area under the curve is equal to 100%. So if it is any of the point is outside the area, we can say it is the outlier. The standard deviation determines the spread of data. A smaller standard deviation indicate data points are clustered close to the mean. Result is narrow curve, while the largest standard deviation indicates a wider spread and flattened curve. So these are the few characteristics of normal distribution. Now let's see what is the imperial rule. The empirical rule, also known as a 68 95 99.7 rule, is a statistical guidelines used to understand how data is distributed in a normal distribution. Here is how it's work. 60% of data fall within a one standard deviation of mean. 95% of falls within a 2 standard deviation, 99.7 falls within a 3 standard deviation. This rule helps us quickly estimate how spread out your data is and whether any values are outlier. It's a specifically useful in a field like quality control, finance, and data analysis. Now let's see when to use and when not to use a normal distribution. You can use a normal distribution when the data is a continuous data. Normal distribution is a most appropriate for continuous data where values can fall anywhere or a continuous scale. Example height, weight, temperature, time. Second one is whether the data is symmetrical, meaning that values are equally likely to be above or below the mean. Third one is a central limit theorem. This theorem states that the sampling distribution of a sample mean will approach a normal distribution regardless of the population distribution as the sample size increases. You can avoid the use of normal distribution when the data is skewed and if the data has a many outlier, if the distribution has a multiple peaks, it's not a unimodal. Now let's see binomial distribution. So, ever flip a coin and wonder what a chance are getting hit 3 out of 5? That's exactly what a binomial distribution is. All about calculating the probability of certain number of successor in a fixed number of tries. A binomial distribution is a discrete probability distribution that describes the probability of achieving a specific number of success in a fixed number of independent trials. The outcome of one trial does not affect the outcome of any other trial, where each trial has only two possible success outcome, one is success or a failure. It's defined by the two parameter n and p, where n is the number of trial and p is the probability of success in a single trial. These are the characteristics of the binomial distribution. First one is a fixed number of trials. The number of trials is predetermined and does not change. Independent trials, the outcome of one trial does not affect the outcome of other trials. Two possible outcomes, each trial result in either success or failure. Constant probability of success, the probability of success is the same for each trial. So this is a formula to calculate a binomial distribution. The formula is probability of x equal to k equal to n c k, where n is ck is a combination and p of k with the probability of success and 1 minus p raised to n minus k, where n is the total trial, k is the number of successors, and p is the probability of success, and nck is a combination. Here is the formula of combination, that is nothing but a n exclamatory divided by k times exclamatory into n minus k exclamatory. So this is the how we can calculate a binomial distribution. Now let's try a simple example. Suppose you flip a coin 5 times where n equal to 5 and the chance of getting head is a zero point 0.5. What's the probability of getting exactly 3 heads? So here is a n is a 5 and k is a 3 and the probability of p is equal to 0.5. So after adding all these values into the formula, we are getting 0.3125, so that there is a 31.25% chance of getting exactly head in 5 flips. This is how you can calculate a mean and variance. This is a simple formula to calculate a mean and variance for the binomial distribution. You can avoid the use of binomial distribution when outcome are not binary, when trials are not independent, and when the probability change between trials. So the binomial distribution is a simple but a powerful helping us understand the chance of success in a real world, one trial at a time. Now let's see a Poisson distribution. So how many customer will walk into the store in the next hour, or how many phone calls will a helpline number get per minute? When you are counting rare event over time, the Poisson distribution is your go-to model. The Poisson distribution gives the probability of number of event occurring in a fixed interval of time or space, assuming the event happen independently and constant rate. So these are the few characteristics of the Poisson distribution. First one is a discrete distribution. The Poisson distribution deal with the count data, meaning it models the number of occurrence of an event which can only be a whole number, example 0, 1, 2, etc. Next one is a fixed interval. The distribution model events occurring within a fixed interval of time or space, such as a number of phone calls per hour or a number of defects per square meter. The third one is the independence. Events are assumed to be independent of each other. The occurrence of one event does not influence the probability of another event happening. Rare event, the Poisson distribution is often used to model rare events, where the probability of event occurring is low, but the average rate is known. So this is a formula to calculate for the Poisson distribution. Now let's see a simple example. Suppose a call center gets 2 calls per minute on average. What is the probability is it's getting exact 3 calls in a minute? So is a lambda is a 2 and p is a 3. So after adding all this value in a formula, so we are getting 0.180. So there is a 80% chance of 3 call in a minutes. So in Poisson, both the mean and variance are equal. You can avoid the use of Poisson distribution if the rate of event change over time, if the events are not independent, if you are measuring continuous data. Poisson distribution helps you understand the rhythmic or randomness predicting how often rare event happen is a state flow. Now let's see a uniform distribution. Imagine a rolling a fair die, every number has the same chance of showing up. That's a perfect example of uniform distribution where everything is equally likely. The uniform distribution describes a situation where all outcomes are equally likely over a certain range. There are two types of uniform distribution. One is a discrete, another is a continuous. In discretes, all individuals' values have a same probability, but in continuous, any value between two real numbers it is equally likely. For the discrete example is rolling a six-sided dice. Each outcome has a probability of 1. And for the continuous, selecting a random number between 0 to 10. So this is a formula for discrete and continuous to calculate a discrete uniform distribution and continuous distribution. The uniform distribution is the fairest of them all, simple, equal, and unbiased. Perfect for when you don't want to play favorites with your data. Now let's see a Bernoulli distribution. What's the probability of winning or losing a game, flipping head or tail, passing or fail? That's what the Bernoulli distribution is all about, the distribution for outcome with just two probabilities. The Bernoulli distribution model is a single trial with only two possible outcomes. It's flipping a coin once either head or tail, no in between. So this is a simple formula to calculate a Bernoulli distribution. The Bernoulli distribution is likely flipping a digital switch. It's either on or off, success or failure. It's a simple, but it's everywhere in statistics and AI. Thanks for watching the video. We'll see you in next one.